I'm recording this meeting, so I'll share with other people who couldn't join today. First and foremost, thanks a lot for joining. Today we're going to talk about the new product that we've been working on for quite some time now. And then this product is all about AI agents that's fixing IT issues on workstations as well as cloud. So we're going to do a little bit of slides first. We're going to discuss why we built this product in the first place, what those agents are, how they work, and then we will go with a very small and quick demo of how things work. And of course, you can ask us any questions and we can discuss any things that would be useful. So every company relies on IT, and the experience seems to be broken on both sides. First, if I'm a user, if I'm having a problem, slow computer, disconnecting VPN, I need a password reset, I need to open a ticket, and then once I do, I always wait. And I get into the queue and I wait until someone helps me. It's actually worse on the other side, where on the IT side, 70% of the work is always repetitive L1 work. And then it feels like you're always grinding on tickets and you're always perpetually behind. So that's why we decided to explore the options of how we can help in this area. And the first thing we did, we looked at the existing tools. Probably you have tried some AI already and looked at some of the chatbots that are positioned in the space. And then probably you quickly discovered that most of them today can only answer questions. And then those are very high level integrations with your documentation system or some ticketing system, and then they can summarize and answer some basic information. Of course, everyone is using ITSM or ticketing system, and for most part, that system can only route and triage and do some basic automation. But for most part, the ticket still needs to be worked on and resolved by a human. There's a number of cloud automation tools, and some of them are really great, commercial and open source, and some of them even provide basic integrations with AI agents. But then you can quickly see that most of these tools cannot do anything on the endpoint, right? They can't reach the device and they can't really investigate or act where the problem actually originates. And of course, everyone is using scripting. Scripting is very static and rigid. It is designed for a specific problem, and the moment the problem deviates and the state changes, scripting typically fails and it's not very dynamic. Right, so the landscape today, chatbots can only answer, ITSM can mostly route, cloud automation cannot touch the device, and the scripting cannot adapt. So what we wanted to do, we wanted to change the experience and come up with something really simple, right? The flow for the user we envisioned is pretty intuitive, right? The first thing is employee opens an agent, an app, or the employee goes to a chat interface that they're using, Slack or Microsoft Teams. And what they're doing, they're describing the problem in plain English, right? Describe what they want to resolve or what they need help with. The agent will do the planning. Before anything is done, the agent will analyze the intent, understand what needs to be done, and come up with the plan of how to fix the situation. And the agent will collect and diagnose the device with the live information and the state of the machine. And then it will proceed with calling various tools to fix the issue or help. And of course, anything that needs approvals will be shown to the user, and all the gates and security gates will be cleared, right? Very simple. Ask, plan, diagnose, approve, and fix. That's basically the flow we've been designing with our agents. So three things make this different, right? As I described, if you compare this with other solutions on the market or anything that you've used before. The first one is reach, right? And the surfaces. Being on the device allows us to do anything on that device. And of course, it also allows us to use any cloud tool. So agent that runs on user endpoint can operate on the endpoint, and it can also go and do anything in the cloud. The second piece, LLMs are part of every flow that we're using, and that's how we achieve reasoning, right? LLMs are used for various things. One is you understand the user intent with LLM, right? Basically, when they describe something, you understand what they want. The second thing, LLM is doing all the planning. And the third, LLMs are doing all the tools interpretation, right? If some tool is called and that tool generates some output, like I'm doing a disk scan, or I'm analyzing the printer issue, or I'm looking at the browser caches, every output is not hard coded like in scripts. Every output is analyzed and interpreted by LLM. And that's the reason we call this reasoning. And the last piece is we build a set of guardrails around our system to make sure that everything is executed safely and securely, right? It's not like you allow agent to do anything on the user workstation. The agent is operating within the guardrails, and it's operating within the playbook, which we call skills, that you define for the agent. The first agent is, as I mentioned, endpoint support agent. This is anything that runs anything that the user needs on the workstation, right? Any computer issue, any application problem. It can also go to the cloud to do password reset, access requests, group management, and more, right? You can think of this as a desktop application that is representing an agent, and it interacts with the user to fix any issue. The second agent is what we call triage agent, right? This agent is actually resolving any issue that doesn't have any playbook, or it doesn't have anything defined from your side, right? The user might be asking something that you haven't thought of, or you haven't created the playbook yet. And you can think of this as a catch-all agent with the purpose of classifying the intent, then understanding what the user wants, and then creating an enriched ticket for you. An example might be the user is having an issue with some sort of hardware peripheral like USB drive, and then you haven't created a skill or playbook for that. And then when the user asks for it, the agent will collect additional information. It will collect diagnostic from the machine. It will package everything into a ticket, and it will create a ticket in your ticketing system. And then that agent will also assign certain attributes or variables that you need when it's creating a ticket. So the ticket goes to a proper queue, it goes to a proper person, and it has the proper urgency, priority, category, and things like that. So you can think of this as basically a routing agent on the user workstation. And the last but not least is the cloud support agent. This agent is basically a headless agent running in the cloud. It's not interacting with the user. It's designed for you as an admin, or it's designed for programmatic interaction, right? So you have some sort of alert that comes in that you want to use to kick off the agentic flow. For instance, you have some alert from RMM, and then based on that alert, you want to kick off a certain playbook. So this agent is exposing a webhook upon triggering which you can actually run certain playbooks, right? So this way, once again, something that interacts with the user and helps user resolve the issues, something that's catching everything on the endpoint that's very generic or a new problem, and something that's interacting with your existing systems. So this way we can capture pretty much any flow on the endpoint or cloud and automate it using our LLM playbooks. So this is how the system works at the high level. Of course, there are many nuances underneath of how the system works, but these are the primary components of how we've architected our agents. So obviously, everything relies on LLMs. And as I mentioned, LLMs are interpreting intent. They are collecting user information. They are coming up with the plan. And then they're also operating and interpreting the tools, right? As I mentioned, if you need to clear the browser cache and see the output of that action, and then decide what you do next, this is what LLM is used for. So the tools are deterministic code-reviewed functions, and each one carries a certain functionality, and it declares its own risk, right? For instance, a tool might be to perform a disk scan, right? We developed this tool on the endpoint for macOS and Windows, and when LLM needs to understand how much space is used on the workstation, it calls this tool, and then that tool deterministically executes this action. So obviously this tool is a very low risk because it's just doing some reading on the workstation. Something like deleting files or deleting empty trashes is a high risk tool, and that tool will first ask the user permission before executing anything. So the big difference is that LLM is not generating any code that is being executed on the workstation. The only thing that LLM can do is to call the tools that you define in the playbooks. So this is a good balance between deterministic action on the workstation and still giving you the flexibility of coming up with the flows that involve reasoning. So skills are playbooks. You can call them playbooks, you can call them runbooks. Those are basically markdown files that you write to define what you want the agent to do. You've all seen Claude skills or Codex skills, or basically any skill that defining what LLM needs to do. And I'll show you later on how those skills look. But that's basically a set of instructions that you want agent to do with some explanation and some conditions and some tool calling. So basically you can achieve a specific use case. So guardrails is the system that checks, that sits between the AI agent and your machines. And it's basically a code that we've written that identifies, that basically implements safety measures. And we'll take a look at what specifically each guardrail does. But there are 4 gates for every execution on the workstation. And obviously there is a cloud management plane, and then the cloud management plane allows you to manage every agent, define the skills, distribute updates, see the runs, understand costs, and things like that. And again, I'll show you how the management plane for this works. So once again, a big part of our time went into making sure that the system executes safely. And then as a result, we came up with 4 gates that every execution that takes on the agent side, on basically everything that agent does goes through these 4 gates. So one is when the user asks something of an agent, the first thing we do is we try to identify if this is a legitimate IT request, right? If a user is asking about the movie tonight, or the user is trying to extract some information or do prompt injection, whatever the intent might be, if it's not mapping to an IT request, this is going to be blocked, right? This is using a variety of code tools as well as some additional LLM reviews before anything is executed or planned. The second gate is the planning gate, right? We operate on the plan then execute architecture. So when the user asks to fix a disk space before anything the agent touches, it comes up with a plan. And then that plan is checked for validity, it's checked for any hallucinations that might have happened, it is checked for the tools that are being proposed, the risk of those tools, and it's basically making sure that the plan is sound and the plan is applicable for that specific use case. So the third gate that we use is an option to use incorporate your company policy, right? What tools are allowed company-wide and what tools are not allowed, what risk is allowed for certain users, for groups of users, and things like that. And the last piece, before every tool executes, the user is given an option to preview and consent, right? If the user doesn't want to do anything, a certain action, they have an option to do so. For instance, and I'll show you later on in the demo, if the user is presented with an option to clear the trash and then clear the browser cookies and then delete certain files, the user can choose which actions they can do, and basically they can do everything that's recommended to achieve the best results, or they can actually choose what actions they would like to do on the machine. So now let's quickly go through the demo and see how things work, right? You're all familiar with our portal if you're using our control product, but we've introduced a whole new section for managing AI agents right now, and I have a couple of them installed. the installing an agent is very simple. You basically go and deploy on macOS and Windows. macOS requires some permissions. The agent is going to ask for permissions when the users execute certain flows, but obviously it's recommended to deploy the agent with an MDM profile, so all the permissions and everything is addressed in advance. And then again, it's just a simple installation script that will automatically install an agent. And like we do with our existing control agent, you can push it out with any deployment tool. We support multi-tenancy, bulk deployment, and things like that. So once the agent are installed, they show up in the portal. And in terms of skills, we've come up with a baseline endpoint skills that are allowing you to address certain actions and certain problems like network reset, VPN repair, slow computers, things like that. And that's what we want to do with our early design partners. Is basically you can guide us through what sort of tools and what sort of flows you want us to enable, both on the client side as well as an endpoint. I'll give you an example of how the disk cleanup skill works and how they actually look. Right, so the skill is just a set of instructions for LLM that involves some descriptions, how the skill is named, what it's used for, what tools it can use, and things like that. You define when this skill needs to be used. For instance, right, if the user is complaining about the low storage, or the user is complaining about what's consuming my disk space and stuff like that. So you just give LLM some prompts, the similar prompts to what user might ask when they are facing this issue. And it's very easy, right? If the user needs to do a password reset, you just give some examples of what the user might ask when they need to reset the password, and basically defining the problem this way. And then you go with the certain steps that you want an agent to do. You can think of this as a set of instructions. Basically, like step one, you identify large folders. You look for certain duplicate files. You check downloads. You check application caches, and then you do some diagnostics. And then you present the user the findings in a structured way. And again, there are various tools to interact with the user in that flow. And then once you present these findings, you do certain actions to clean up, right? For example, in this case, you're looking at large files and propose the user to delete the large files that were found. You look at duplicates, and then if there are any duplicate found, you give the user the option to delete those files. If the user is a developer, there's going to be things like developer cache or Docker images and stuff like that. Then you propose the user an option to clean up those as well. So writing those skills is very simple. You just define what tools you want to call, and if there are any conditions you want to put on that, you can actually do that as well. So in our system, we provide you two options to write these skills. And again, we can help you write those skills depending on the flow you want, but you can obviously tweak those skills based on your needs. One option is you can write a manual skill. You can take our existing skill as a markdown file, tweak it based on what you need, and you can simply upload it and test it for your use case. We also provide a very simple skill builder where, for instance, if I want to do printer troubleshooting when the printer breaks, you can create a custom skill. That's going to be a guided editor here showing you various steps and tools you can add. For instance, if I want to add the printer here, the tool gives you the information about the inputs it takes, the parameters that it expects, and the outputs it generates, and you can basically use this as a similar fashion to what you're accustomed to designing existing automation RPA flows or things like that. So again, it's very simple. Either you upload the skill in a markdown file, and again, you can see the examples that we've built, or you can use our skill builder. It's a guided flow. You can even use LLM to generate an initial skill and then start off that and then edit it based on your requirements. Every run that you have in your environment is basically uploaded to the cloud. You can review what was done, how much the run cost, what tools were invoked, and things like that. So everything is audited in the cloud. And obviously, for integrations, if you connect our system to your ticketing system, all this information will land in your ITSM tool as well. So let's try to look at a very simple example. I am on this workstation and I have the agent installed. As you can see, the agent is just a familiar interface. It provides you an option to chat and describe the problem you're facing. We also provide this option on the left, which we call pills. These are, and again, these are controllable from the cloud. You can define which skills show up on the left, and by clicking a button, you can trigger those skills without defining the problem. So let's say I am having an issue with disk space. So if the user is basically having an issue with something, they can type it up, and what the agent will do, it will try to map it to existing skill. And if the skill is not found, the triage flow will kick off, and the user will be asked for some more information, and diagnostics will be created. And then the ticket will be created in your system. If the skill is mapped, like in this case, it was trying to identify the workflow, and it mapped it to the clean disk skill. Now it will start executing and planning everything. So in terms of the models, we provide integrations with various models today. For instance, you can use Anthropic models. Those are very high quality models. They will be very fast, and then they will be using a certain amount of tokens, so the cost per run will be a little higher than some other models. In this case, I'm using DeepSeek integration, and then these models are a little slower, so the planning might take anywhere from 60 seconds to 100 seconds, but the cost per run is going to be much lower for you, and we will see how much that will cost once we make this run. It's really up to you what sort of experience you want to enable. And again, for our early design partners, we are basically allowing you to use this without any markup. You're only going to be paying for the cost of LLM models. So as you can see, it started executing and looking at all this information based on the skill. It's scanning the disk on this machine, collecting the large files, finding duplicates. Everything you saw in that text, the playbook that I showed you before, is being executed on this workstation right now. As a first step, it collects all the diagnostic information. So that's why you see all these tools here that basically saying get, right? It's not doing anything, but it's collecting all this information. So I intentionally placed some large file on my desktop. I intentionally created some stuff in my trash, and I intentionally browsed the web to generate some cookies. So as you can see, it identified certain pieces of information. It gave me the large files information, found this file on my desktop. There's a number of duplicate files, the number of caches, and what's generating these caches, and then there's something in my trash. Obviously, the user can choose what they want to do. In this case, for the demo purposes, I'm gonna execute everything that this agent is suggesting. So if I continue, now the system is going to take actions on the workstations based on the tools. The first thing is it's trying to delete this large file on my desktop, and this is where this execution gate comes up. It's asking the user, hey, you're gonna preview this, I'm gonna preview this with you. Before you proceed, I'm gonna delete this file. If I proceed, I do the final confirmation, and then that file is gone from my desktop. Now it's gonna start deleting some duplicate files that it identified. It's some sort of files that I used on this workstation. And then the last but not least, it's asking me to preview that it's gonna clean 200 megabytes of storage from my trash. And once I do that, my trash is also cleaned up, as you can see. Now it's going to do one last disk scan to understand the delta of what was the disk space before and after, so it can generate the summary for a review. Now, we're going to give it some time once it processes everything. And now it's going to summarize me what was done to the user. So this is the summary. You're also going to see if there are any issues that have been encountered or any tools failed or user denied something. You will always see this in the summary. The system is always going to ask the user about the feedback. The user can provide additional options if needed, but in this case, I am happy with the result, and I'm going to submit a positive review. Now, all this information is going to get packaged and sent to the cloud. We also can create a ticket in your ticketing system even for successful runs, so you have an auditability. For instance, the user complained about something, the issue was fixed, then we create a ticket and automatically close it in your system. So you know that something was done, and you can always track this in your ticketing system. So let's go back to our cloud portal and let's go back to our runs. As you can see right now, I have a run for I'm having an issue with the disk space for this user on this machine. It was resolved. With DeepSeek, it cost me 1 cent to execute this run. And this is one of our more intense runs in terms of the tokens that are being used. So some of the lighter runs are going to cost even less. And now if I look into this run, you basically have everything that this run represented, right? The run status is resolved, all the tools executed, and the user marked this as resolved. So the user is happy with the result. So the skill that was matched is the disk cleanup. You can always see what the skill is representing and see if you have your custom skill, you can see exactly what the system was relying on. This is the summary we saw in the chat, that basically what was done, and you can quickly see what if there are any denied tools or any issues happened during the run. So for every tool run, we give you an output. For instance, if you want to see what the disk scan is and what the output is, you can go to the tool activity section and see the outputs, right? These are the specific things that were, it looked at all my folders on that machine, and it looked at all the sizes, and these are all the tools that are being generated. Once again, every tool is a deterministic tool. It's not something LLM invents. It's not something that will be hallucinated or interpreted. It's basically a piece of code that LLM called on the machine. It called the disk scan executed and returned certain information, and that information was interpreted by LLM and also uploaded to the cloud. So and you can also see what files it deleted, what caches it cleared, that it emptied trash, and things like that. And then in the context, you can see that everything about the run, what's the host name, the user, the information about the model that was used, the output and input tokens, how much cache tokens we used, and things like that. And obviously the number of LLM calls that we used in the loop and the cost per run. I think that's a basic example. What I didn't show you today is how we do integration with the chat platforms like Slack and Teams. So you can trigger the execution flows from those chatting platforms as well, if the users prefer to do so. I also didn't show you the ticketing integration, but today we integrate with Halo, we integrate with ConnectWise, and we provide various mappings to the fields of how to create tickets, and that is also very flexible. And then in terms of the skills, right, what I showed you today is endpoint skills. Any problem that you can execute on the endpoint, you can start with that. And we're also providing an option to do cloud actions, right? If you want to do a password reset for the user, or the user needs to request certain application or placement in a certain group, anything that requires a cloud action will also be available here in the skill as well. So I think that's a quick overview. If you guys have any questions, we can discuss. We also have Jigjit on the phone who's been architecting this. We can discuss anything that would be useful to you. let me, yes, go ahead. Yes, right now we published, so that's what we need your initial help with. So today we published 6 skills on our GitHub, and those are available as built-in skills on the platform. So what we do today is fixing network issues. We do VPN repair. We do slow computers, where we basically look at the memory processes, things like that. We do disk cleanup. We do printer repairs. We do email repairs, and we do the general triage. So we published 6 or 7 skills today, and we have more in the pipeline. What we are looking for is your input on what specific flows you want to enable. If you tell us basically, hey, here's the flow that I want to do, here's how we as MSPs typically troubleshoot peripherals, or here's how we typically do password resets, or here's how we typically, I don't know, do group management for users. If you tell us what specifically you want, we can quickly write the skill. We can write the skill, and if it's mapping to existing tools, it will be very fast. If it needs some certain tools or additional actions, like you want us to take action in Entra, group management, or you want us to take action in Okta, or you want us to take action, I don't know, anywhere else in your cloud system, we can quickly add up the tool and then propose a certain skill and publish it. And if you need minor tweaks, you can always take that skill, edit it, and upload it using a Markdown editor, and it will be very custom for you. That's how we envisioned it to work. Yes. So, so we envision this will change as we go forward, right? Because we're still iterating on the pricing model and how it will work. So right now, for our early design partners who signed up, we basically give you a bring your own key option, right? Right now, if I go to my MSP portal and I have the care settings, right now we expose 2 models, Anthropic and DeepSeek, and you just provide your own API key. So what you need to do is you register for Anthropic account and get your API key, or you register for a DeepSeek account and get your API key. And that's it. You put in your API key, and it's using that API key for all the runs. It's using that API key for the cloud actions, like you want to generate the skill with LLM. It's going to use that API key, and every agent is going to use that API key as well. So we're in the process of testing OpenAI as well. So OpenAI will probably get added soon as well for as another option. And again, based on the feedback, if you guys are using any other models or you find any other models useful, we can also integrate and incorporate that. So we found Anthropic to be very good for reasoning today, right? We've been using Sonnet, not even Opus, but we've been using Sonnet. And even Sonnet is enough to understand what's happening on the endpoint and come up with the plan. It's a very good model. It's very fast. So what you saw I was demoing today, Anthropic is probably going to be 2 times faster, but it's going to cost you significantly more, right? Every run is going to cost much, much more because Anthropic is more expensive. DeepSeek, we're using the Pro model, so we're not using the Flash model, we're using the Pro model. That model is also very good. It gives us satisfactory results for all the runs. That's why we chose it. It's very, very cost effective, as you saw. It costs literally nothing per run, but it's a little slower, right? Just because the API from DeepSeek is a little slower, the planning might take a little longer for that model. I think Jagjit can chime in and answer more on this. I think the idea was that our own harness and agent is handling all that. So we are already using all the caching, as you can see. Like if I go to the run section and I look at the last run, you can see that we are already using the cache tokens for the most part. Everything that the model allows us to do, we're trying to implement. And we are optimizing the LLM calls when we run the loop. And we're also optimizing the context management of how we package all these things in the context window. So the goal was to basically abstract all this. The goal was very simple. You provide an API key, and we're trying to make it as effective as possible. Jigjit, you can chime in if I missed anything. Yeah, let's go to this, right? So let's go to these guardrails here. There's four guardrails. So if I go back to this, let me go back to this machine and open the new chat, and I'm gonna say, what is the movie to tonight? So the very first guardrail is we are mapping everything, which is what we call intent, right? Intent guard, we call it gate. There's four gates every execution passes. So the first one is intent. Anything that's not IT related is blocked, right? The way we do this is a combination of LLM and code, basically a combination of regex, pattern matching, as well as LLM review, right? So the first request comes in, we try to classify it, and there's a multi-stage classification. And if it doesn't resemble anything that's IT related, it's going to get blocked, as you can see, right? So that's basically looking at, and it provides you option, okay, I can help you with these things, but I'm not going to be help you with this request. So that's what intent is doing. The second gate, once it passes the first gate, an LLM comes up with the plan. So once the plan is generated by LLM, we use another LLM to basically review and assess that plan. So this way we catch hallucinations. We catch the fact that some completely random stuff creeps up into the plan. We catch things like wrong tools being used completely out of context, right? If I'm troubleshooting a VPN, why am I using some sort of random tool for deleting files? We also catch things like risk management. Every tool declares the risk, and if there's a certain threshold of risk that exceeds, we basically invalidate that plan and ask LLM to rewrite that plan. So there's multiple steps that happen when the plan is being generated before that plan is actually accepted. And once the plan is accepted, it's a contract, right? Once the plan is done, and again, once you guys try a product, you can see the logs and everything, and you can see how the plan is generated in the logs and stuff like that. Once the plan is generated, it's a contract. LLM cannot do anything that's outside of that plan, right? Once the plan is agreed upon and the tools are agreed upon, that's the only thing that's being executed. The third one is policy. Policy allows you to upload certain configurations in our cloud, and we also expose integration with some systems for like enterprise customers and stuff like that, where you can define things like this tool is not never allowed for this group of users, or this tool is never allowed for this set of devices and stuff like that. If there's any organizational policy or any or I want to enable this skill for MDM managed devices and this skill for non-managed devices. So anything that you would envision enterprise would want goes into the policy. It's a structured input to our model that allows it to filter out certain actions as well. And the last but not least is execution, right? This is what you saw when I was doing a demo. It's doing two things. It's previewing with the user, and it's actually confirming with the user. So that's what we call a dry run and confirmation. So when the user is offered to delete the file, every tool that's doing that action is previewing that action. So it's showing you, hey, if you execute this action, here's what's going to happen. This file will be deleted. So the user knows if I execute this action, what exactly will happen. And then the last but not least is you're always confirming a risky action, right? If I'm doing a trash cleanup, the first thing it's gonna do, it's gonna say you're deleting the trash, here's how much space you're gonna clean up, and here's how much stuff will be deleted. Are you sure you want to do that? Right? That's basically the execution gate. So every run goes through these four gates, and then they always execute. And as we test the system, as we basically collect telemetry, we're always tweaking these gates to make sure we're catching the intent. And what we found out as we've been discovering, every model behaves differently, and every model behaves differently as it relates to these gates. So for us, it's not just enabling an integration with, I don't know, OpenAI. For us, it's a matter of using a specific OpenAI model and then looking at how that model behaves through each one of those gates. So that's what we've been doing when we've been certifying Anthropic and DeepSeek. Yeah, I think our offer for quite a number of people signed up for our early engagement and design partners. And after this webinar today, tomorrow, I'll reach out to everyone. What we envisioned is we work with you guys and help you design all the flows, and we help you implement them successfully. Everything you can see everything that the model is doing. You can see all the runs and auditing. The mapping, the matching is not actually a problem, because if I go, for instance, to this code review and the skill, right? Uh, when the model is trying to map the skill, it's looking at various options. So the first one is description, right? If you put something in description, you're telling the model, use this skill when something like this happens. It's basically a statement of when this skill needs to be used. Then, in addition to this, you have a full option to write when to use. You can specify as many examples here as you want, right? For instance, if you have a disk cleanup, like in this case, you can give it like 50 prompts of what the user might ask. If you have specific tools or specific files or whatever, just mention it here and it's going to map that. And then once it's not mapping that, the triage flow is going to kick off. For instance, if you can kick off, we call it report issue. And again, this is where we need feedback, or I can describe something that's completely outside of scope. Let's just go and kick off the new. I have issue with my Citrix application. So obviously, right now I don't, let's see what the model is going to do. I don't have any issues. Right now it's going to ask me, hey, I need more detail about this. I'm not able to map the skill. I can choose the skill as I want, or I can say I'm going to report an issue right now. And then once I report the issue, it's going to kick off the triage flow. And that triage flow today is going to basically collect some additional information as a form and create a ticket for you and create some diagnostics. I'm going to show you a triage skill. And again, that triage skill can be edited. Let's see, this is a triage skill. It's going to basically generate a form for the user, interpret intent, generate a form for the user. It's going to map it to a certain category. Again, these categories are editable. You can edit any category you like based on what you're using today. It's going to assign the urgency. Like right now, you see it's giving me this pre-filled form. It already interpreted that it's a software issue, priority medium, user reports issue with the Citrix application, affected system Citrix. I can edit this as a user, and then I can escalate this to you. And you on your side, you can basically say, hey, I want different categories mapped to different priority, right? And then that's how the system is going to behave. And once the system is behaving that way, you can then decide what specific diagnostics you want to collect. So what you want to collect for network, right? If the user is complaining about network, you want to check the connectivity and use any of our existing tools. So when the ticket lands in your environment, you already know what this is, and then it already attaches all the information that you would need for that category. You can define the edge cases. I mean, all of this is editable. And again, we can help you design all this. And once that is done, once I escalate to IT, now it's going to go and map it and create a ticket in your ticketing system. So all of this, again, is in the logs, it's in the portal, and we will help you design all these flows. Yes. Yes, that's a great one. So this is what Jigjit is almost done with his team. We call it proactive triggers, right? So proactively, we will allow you to monitor certain pieces of information, like a disk space, and then once that disk space crosses certain threshold, uh, you can execute a certain skill proactively. So the user will have a pop-up like, oh, we've noticed you have a disk space that's running low. Let's execute the skill for disk cleanup. The user confirms and it goes through the same flow. So we envision that for every skill, you will be able to define a set of proactive triggers, right? You can ping a network connection for certain IP address, and then if that fails, trigger network fixing skill, stuff like that. So that's what we're going to be releasing soon, and that's what we call proactive triggers. I don't know, Jigjit, if you want to add anything here. Any more questions? I'll reach out to everyone. It's not enabled. It's behind the feature flag. I'll reach out to everyone who signed up for our design partner program, and then we'll start with that. So once again, I'll just say one last time, right? So this is what I showed today: endpoint security agent and triage agent, right? This is all about the user-facing interaction. You install it on the desktop, and it fixes user issues. Can integrate with Teams, Slack. Will do proactive trigger stuff like that. Triage agent is all about doing triage and collecting information that's not mapping any skill. And cloud support agent, again, we've developed this because of the early feedback of people saying we want to do admin initiated flows, we want to do webhook initiated flows. So this is a headless cloud only agent that runs your own flows, like if you need to onboard the user, offboard the user, things like that. Once again, I'll reach out to everyone who signed up. We will help you set up all the flows. And then what we're looking for at this point is as much feedback as you guys can help us with so we can improve the product. Once again, thank you for your time. I'll circulate all this information and recording after the call, and looking forward to working with you guys on this. Yes, go ahead. Yes, this is the cloud support agent. So this is what the this is only triggered by the user, right? I need help. You can chat with it. You can basically send it on Slack. You can send it on Teams. You can start in our own app. This is what the endpoint support agent is. The cloud support agent is a webhook. You can envision this. I have an alert in my RMM. RMM is going to post to a certain webhook, and then that will trigger a flow. Or I am troubleshooting the ticket and I call a certain URL from my ticketing system, and that's going to trigger a workflow. Or the user sends an email and the email system posts to my webhook, and that triggers the flow. So this is a headless agent. All it does is it gives you a webhook, and anything that posts to that webhook will basically trigger a flow. So that's a little further out, but that's what we're at the basically finalizing the design stages and architecture right now, but that's something that we will be working on as well. Thanks, guys. Highly appreciate your time, and thanks a lot for attending, and thanks a lot for helping.